So welcome to the lesson. The subject is Advanced Financial Management. Today we begin on a new topic, Portfolio Theory and Analysis. This topic has 5 subtopics. 1. The modern portfolio theory. 2. The capital asset pricing model. The third subtopic, international CAPM and behavioral CAPM. Subtopic number 4, the arbitrage pricing model and other multi-factor models. The last subtopic is evaluation of portfolio performance. 5 subtopics. Portfolio theory and analysis. We are required to study the background of the theory, portfolio expectation return, the actual and weighted portfolio risk, derivation of efficient sets, the capital market line and its applications, the mean variance dominance rule, and the shortcomings of portfolio theory. Now, candidates, firstly, let's define terms and the key concepts. Portfolio theory. What is a portfolio? First of all, what is a portfolio? A portfolio is a collection of various assets such as stocks, bonds, real estate, and other investments. So if an investor has 2 or more investments, then we say the investor has a portfolio. It is a collection of various assets. It could be 2 assets, like stocks in company A, bonds in company B. So the 2 assets, the collection of the 2 assets, the stocks in company A and the bonds in company B, that is a portfolio. It's like having a basket that holds different investments. So that basket is what we are calling a portfolio. So it is like holding different investments in a basket, each with its own potential for risks and returns. That's the meaning of portfolio, a portfolio. Now, in the syllabus, we are required to study the modern portfolio theory. The modern portfolio theory. Modern portfolio theory. That implies that we have a traditional portfolio theory. Now, this modern portfolio theory was introduced by a man known as Harry Markowitz. The man behind the modern portfolio theory, his name is Harry Markowitz. Harry Markowitz. Right? And this is in the 1950s. Just the other day. Okay, 1950s. This is the modern portfolio theory. But before Harry Markowitz introduced the modern portfolio theory, investors had been constructing and managing portfolios for centuries. And while these early approaches lacked the what I may call mathematical rigor, the traditional portfolio theories lacked the mathematical rigor. Of course, we had the traditional portfolio theories where investors understood the idea of having different assets, holding different assets with a view of diversifying risk. That is an old idea. It's not Marquis who came up with it. So the traditional portfolio theory lacked the mathematical aspect. While they didn't have that quantification of risk and putting figures to uncertainty and all that, these traditional approaches laid the foundation for modern investment principles. You understand? So we are not getting into the traditional portfolio theory. We are required to focus our attention on the modern portfolio theory that was introduced by Harry Markowitz in the 1950s. So the portfolio theory, specifically the modern portfolio theory, we can define it as a framework that helps investors to construct portfolios that maximize returns for a given level of risk. It is a framework that helps investors construct portfolios, and have it at the back of your mind that a portfolio is a collection of different assets, is a set of assets. So this theory helps investors in constructing portfolios that maximize returns for a given level of risk. So that's why our focus will be mainly on just risk and return. And candidates, the modern portfolio theory is based on the idea that diversification, which means spreading of investment across different assets, can reduce the overall risk. That's a cornerstone of the modern portfolio theory. Diversification. That means holding different assets, combining different assets with different features can help investors to not only increase their returns but also to minimize risk, the overall risk. So, candidates, I'm repeating, modern portfolio theory. Modern portfolio theory is a framework that helps investors construct portfolios that maximize returns for a given level of risk. It is a framework that helps investors construct portfolios that maximize returns at a given level of risk. return, risk, return, risk, return, risk. The theory is based on the idea that diversification can reduce overall risk. Diversification is based on the idea that diversification can reduce overall risk. Diversification can reduce overall risk. You understand? And behind this theory is a gentleman known as Harry Markowitz, who was even awarded a Nobel Prize in 1990 for his groundbreaking work. In 1990, he was awarded the prize. Have you understood the basic idea? And from your syllabus, candidates, we are to give the theory some background of the theory, background. Now, by background, we are referring to the traditional portfolio theory, which emerged in the 20th century. The portfolio theory emerged in the 20th century at a time when investors were primarily focused on individual stock selection. So the theory primarily focused on individual stock selection. Please note that, because it is Markowitz who challenged that idea. In the mid 20th century, investors primarily focused on individual stock selection. When I say stock, candidates, I hope you understand what I'm talking about. You are not younglings, you understand stock. So in the mid 20th century, investors primarily focused on individual stock selection. But Markowitz challenged such what we call conventional wisdom. This was in the 20th century, mid, okay? So Markowitz challenged the idea of focusing on individual stock selection by emphasizing the importance of portfolio construction and diversification. But before the modern portfolio theory, in the mid 20th century, before that, candidates, investors often relied on subjective judgment. Investors relied on subjective investors relied on subjective judgment. Okay, they relied on their own intuition without doing calculations for portfolio risk, portfolio returns, and all that. So these are just qualitative aspects. They relied on qualitative judgment, okay, subjective judgment on which investments to undertake, what combination, and so on. So Markowitz introduced a quantitative approach that allowed investors to systematically analyze the risk and return characteristics of portfolios. So I want you to see the progression. We are studying the evolution so that we can appreciate what manner of contribution Harry Markowitz introduced. So before Harry Markowitz introduction of the modern portfolio theory, the investors relied on subjective judgment and intuition. They relied on qualitative judgment. Then came Markowitz, who introduced quantitative approach that allowed investors to systematically analyze risk and return. These are risk and return characteristics of portfolios. So now here you can see candidates, they shift towards a more data-driven and analytical approach to portfolio theory. And since then, it has revolutionized the field of investment management. And over decades, the modern portfolio theory has continued to evolve and to adapt to changing market conditions and investor preferences. You understand? Of course, it has its own limitations, which we'll study later on, like relying on historical data, assumptions of normal distribution returns, difficulties in incorporating non-financial factors. But despite such limitations, the modern portfolio theory remains a fundamental tool for investors, a fundamental tool for portfolio managers, and it provides a solid foundation for understanding the relationship between risk and return, the benefits of diversification, and also the importance of asset allocation. And by applying the modern portfolio theory principles, investors can make more informed decisions and also improve the long-term performance of their portfolios. That's why the theory has found its way in your syllabus, candidates. That is how important it is. So briefly, that is the background. Okay, it's the background of or the evolution of portfolio theory. All right, thank you. So let's briefly discuss a few concepts of the modern portfolio theory, some of the key concepts. Let's briefly discuss the key concepts. And the key concepts here, candidates, just have risk and return. One, risk and return. Risk and return. Risk and return. Remember, we say that it is a framework that helps investors construct portfolios that maximizes returns at a given level of risk. And here candidates, risk is measured by variance or standard deviation. Risk is measured by variance or standard deviation. Risk is measured by variance or standard deviation. Risk is measured by variance or standard deviation, and it quantifies the uncertainty associated with an investment's return. This is a financial metric as opposed to the traditional portfolio theory that focused on qualitative factors. The modern portfolio theory measures risk by calculating variance or standard deviation of portfolio, and this risk that is quantified measures the uncertainty associated with an investment return. That is risk. And the return, candidates, is a profit or loss on investment over a specified period. The return is the profit or loss associated with the investment. The second key concept is diversification. When discussing modern portfolio theory, diversification is one of the key concepts. This is the strategy of spreading investments across various asset classes. Spreading investments across various asset classes. It means spreading investments across various asset classes, and the objective is to minimize risk, is to reduce the overall risk, to reduce the overall risk. So by diversifying, investors can mitigate the impact of adverse events on their portfolio. Candidates, I want you to pay attention. We are building a house. We are building a house. Please pay attention. We are building a house. What we are learning now is what we will need as we progress. Is that clear, Omolo and the rest? Where is Gapno Knight? Why are you jumping in and out? Please pay attention. We are laying down the foundation for the modern portfolio theory. Diversification is a process of spreading investments across various asset classes. So if you have money and you want to invest, instead of putting all that money in just one investment, say real estate, that money can be spread into bonds, derivatives, future contracts, and very many or different asset classes. The objective is to reduce the overall risk. Three, efficient frontier. Efficient frontier is another key concept associated with the modern portfolio theory. Now, an efficient frontier is a graph or a curve that graphically represents the set of optimal portfolios that offer the highest expected return for a given level of risk. It is a curve that graphically represents a set of optimal portfolios. A curve that graphically represents a set of optimal portfolios. An efficient frontier is a curve that graphically represents a set of optimal portfolios that offer the highest expected return. That offer the highest expected return. Efficient frontier. We'll get into these concepts as we progress, candidates. Another key concept is what we call capital asset pricing model. Capital asset pricing model, CAPM. The capital asset pricing model. This is a model that relates the expected return of an asset to its systematic risk. Okay? It's a model that relates the expected return of an asset to its systematic risk measured by beta. CAPM is a model that relates the assets. Please take note. The expected return of an asset. The expected return of an asset with its, we are relating two things here. The expected return of an asset to its systematic risk. To its systematic risk measured by beta. So CAPM, in other words, candidate helps investors assess the appropriate level of return for a given level of risk. Again, we'll get into details on CAPM. So this is a snapshot of the concepts of the modern portfolio theory. So candidates, we've been talking about portfolio expected return. We've mentioned measures like the variance, standard deviation, and I'm well aware that you are not getting introduced to portfolio theory for the first time. In your financial management at intermediate level, you had a topic known as Introduction to Portfolio Theory, where you are introduced to some of these basic calculations on the variance, standard deviation, covariance, correlation of coefficient, portfolio return, and so on. So we're going to build from what we learned in intermediate level. So let's have an illustration, candidates, at this point that will help us know how to calculate the variance, the standard deviation, covariance, portfolio return. You understand? Covariance, correlation of coefficient, and so on. Illustration. Illustration. The following information relates to two potential investments, namely investment M and investment K. So we have the probabilities, we have the return for investment M, we have the return for investment K. Required, compute the expected return for each investment. Compute the expected return for each investment. Roman 2, determine the standard deviation of investment M and investment K. Roman 3, compute the portfolio return, assuming that 30% of the total wealth is invested in investment M and 70% in investment K. So first of all, we are required to compute the expected return for each investment, beginning with investment M. Expected return for investment M. Expected return for investment M. We have the probabilities. The first column there is probabilities. Then we have the return. Then there is probabilities for investment K and the return for investment K. So we want to first of all compute the expected return for investment M. So we will get the product or the sum, or we get the sum of the product of the probability and the return. The formula is to get the sum of the product of the probability and the return. You see the return? 20%, 8%, -4%. Okay? This is probability M. Let me use M and the returns for security M. Do you see that? That's the formula. So I'm going to give me the question, please. The probability 0.3, we multiply by 20% plus probability 0.4 times 8% plus 0.3 times -4%. Then we add. So that's why I'm saying the summation. So this will be equal to the probability 0.3 times 20. This is 20% plus probability 0.48% plus probability of 0.3 times 0. Is it 0 point? That's 4%, negative 4%. That will be the expected return for security M. Then the expected return for security K is again the summation of the product of security K times the returns for security K. 0.2 times 20% plus 0.6 times, what is the percent? 8% plus 0.2 times negative 4%. What is the expected return? Investment M, 8%. Investment K, 8% again, 8%. That's Roman 1. Roman 2, we are required to determine the standard deviation of investment M and investment K. So the standard deviation abbreviated as that is the symbol for standard deviation, is equal to the square root of the variance. So to calculate the standard deviation, we first calculate the variance, then we get the square root of the variance. That will give us the standard deviation of security M. We begin the standard deviation for security M. So standard deviation of security M will be equal to the variance of security M, the square root of variance. So we're going to have the variance, then we get the square root of that variance. Variance is a deviation, candidates. It's a deviation. You are going to calculate the values, the deviations. That is x1 minus x bar, the expected return. X bar represents the expected return. All right. So this is the variance. This is the variance. The actual, we deduct the expected, then we square this variance. Okay, we square the variances that we multiply by probability. So this, if you are to, this is the variance, so we get the square root of this variance. Standard deviation. So this is the general formula, candidates. Give me the question, please. The question. So the actual values are given there. The return expects the values shown there: 20% for investment M, 8% for probability of 0.4 and 0.3 probability negative 4%. Those represents the rate of return from an investment proposal. Then X bar is the expected return, which we've computed in Roman 1. Do you see that? Are you following, John? We want to determine the standard deviation of investment M. So we have the returns. Let me use a table. We have the return. There is the return from the question, percentage return for security or investment M, 20%. Next is 8%. Then we have -4%. The probabilities are also provided. 0.3, 0.4, 0.3. These are given in the question. These values are provided on the question. So it is these two columns that give us the expected return. We multiply 20 times 0.3 plus 8 times 0.4 plus -4% times 0.3. When you get that summation, that gives us the expected return, which is represented by X bar. So we have the expected return. This figure, we have it. We calculated it in Roman 1. So we'll have a column for return. This is R1 minus R bar. Okay, expected return. This is the expected return. So this expected return, we are deducting from the rate of return from investment, 20. Do you see that? So we're going to have 20 minus expected return of 8, then 8%, okay, minus 8, then we have -4% minus 8. That is the deviation. Deviation. Do you see that? So the amount we get here, you can see the square there. We square it. Square it. Square the deviation. And after squaring the deviation, you multiply with the probability. This probability. Let me take you step by step. Step by step. We are going to have the probability times R1 minus R bar. You square it. Okay. So I want this value. So 20% minus 8%, square it, times 0.3. What do you get? For 3.2. This obviously just 0. Give me the other value. Negative 4% minus 8%, square the deviation, multiply by the probability of 0.3 for 3.2. Then get the total. Summation. Because this is the general formula, candidates. The total is 86.4. 86.4. This is the general formula. Standard deviation of security investment M is equal to the square root of the variance. This is the variance. Variance, deviation. So which is equal to 86.4. We get the square root of 86.4. That gives us the standard deviation for security M. How much is it? 9.295 is the standard deviation for security M. Standard deviation security K will be equal to the square root of the variance we use the same root. We have the returns from the question. We have the probability from the question. Then we'll have the deviation. This is a return of security K minus the expected return security K times probability. From the question, give me the question. 28 negative 4. This is percentage. 28 negative 4. These are percentages. Probability. What's the probability? The probability 0.2, 0.2, 0.6, 0.2. RK is 20 minus expected return 8 squared multiplied by the probability 0.2. How much is it? 8% minus 8% squared multiplied by the probability 0.6. How much is it? Negative 4 minus 8% squared times probability 0.2. How much is it? Get the total. That is the variance. And therefore, what you get here, just get the square root of it. That will be the standard deviation. How much is it? What is the variance? It's 28.8, 0, 28.8. What's the total variance? That is 57.6. 57.6. So 57.6. What is the square root of 57.6? Square the 57.6. Standard deviation 7.589. What is the other requirement of the question? The question reads, Roman 3, compute the portfolio return, assuming that 30% of the total wealth is invested in investment M and 70% in investment K. That is a portfolio return, return of a portfolio, expected return of a portfolio given the weights 30%, 70%. Roman 3, the expected return of a portfolio is equal to the weight of portfolio M times the return of portfolio M plus the weight of portfolio K times the expected return of portfolio K. The portfolio combination. What is the expected return of the portfolio given the weights? Give me the question. What is the weight of investment M? The weight for investment M is 30%, 70%. So this one is 30%. Convert it to decimal, 0.3. The we calculate it here, it's 8%, plus the weight of investment K, which is 70%, converted to decimal, 0.7 times 0.8, or just 8%. That gives us the expected return of the portfolio. What is the expected return of the portfolio? Now that's it, candidates. We've calculated the standard deviation and the expected return of the portfolio. Now when we say the standard deviation of security M or investment M is 9.25%, what does that mean? What is the interpretation? Because when we began, we say that the standard deviation is a statistical measure that quantifies the amount of variation. It is the quantification. It quantifies the amount of risk. In portfolio theory, standard deviation is measured, is a measure of risk. These are individual investments. So the standard deviation of 9.295 for security M indicates that its returns have historically fluctuated significantly. That is to mean that the securities price can experience large swings both up and down. These are 9 points from the standard. It is deviating 9.295 from the standard. It measures the volatility of securities returns.